Good morning. My name is Virginia, and I'm the co-founder of NYAD. And what we're trying to do is to give wastewater treatment operators more control over their microbes. So a little bit about background about us. My co-founder, Chris, and I here, we are water entrepreneurs from the UK. We previously founded a profitable COVID diagnostics company during the pandemic, and we are big on clean water, being keen open water swimmers. So we've spent the last year or so really diving into the wastewater industry, speaking to experts across Singapore, India, Europe, and the US, and we found that there is a lot of scope for the application of new technologies, and in particular artificial intelligence, to the wastewater treatment space. So we're a concept stage startup, we're early, and I'd like to present a use case to you today of AI in wastewater treatment. So zooming out a little bit first, these are some of the main things we've heard from the wastewater industry about why they are adopting AI. So the first is the rising cost of resources, so namely chemicals, energy, sludge disposal, things like that, reseeding, and also the tightening regulations and the heightening environmental goals that are not getting any easier to meet, and the associated reputational risk of polluting events, spills, overflows, etc. And all this is being underpinned by the difficulty of recruiting and also retaining highly skilled talent at the plants. So operators are being basically forced to achieve more with less resources. And AI is starting to meet some of these kind of challenges because it is often real time, it's continuous, it has an ability to adapt to its conditions and to draw parallels and find patterns in data in a way that humans just never can. So in a world where profit margins and also margin for error are being squeezed and operational efficiencies are often becoming the kind of competitive differentiator, AI is becoming a real crucial tool for them. So what we're doing at NYAD is we are helping operators to make the most and control their microbes. So wastewater treatment plants struggle generally to manage their microbiology, and this is because influent volumes are increasing, the regulations are tightening, and expanding in physical infrastructure to then just dilute their effluent is not always the most practical solution. So the uncontrolled biology can lead to all sorts of issues in their plant. It can lead to poor settling, it can lead to polluting events, and the remedial actions that operators have to take are often expensive. So they're going to have to crank up their chemical dosing, they're going to have to use more of their aerator, which is energy intensive, or they're going to have to do regular reseeding. So the traditional way that they would go about managing the microbes would be, traditional lab-based testing, and it's manual, it's expertise intensive, it's subjective, it's slow. So our hypothesis is that automated biological insights using microscopic images can improve microbial management. And how we're going to do this is with AI. So it's a three-step process. The first is using computer vision. So this is the convolutional neural net that we heard about first thing. And that computer vision is going to analyze a microscopic image of a mixed liquor sample. The next is we'll run that through a machine learning model which can determine the settleability characteristics associated with that image, which then leads on to prediction of settling issues. And the early solution, the MVP, the minimum viable product, will be an early warning alarm, essentially, of microbial upset and potential polluting events. And further down the product roadmap line will be fully automated microbial insights from microscopic images along with treatment recommendations. So diving into the technology a little bit, this is the fundamental shift that's happening in computer science here, is we take a set of data and we take some rules, so an if X then Y kind of equation, run it through the model, and it can spit out an answer. The shift with machine learning that we're using here is that we take a set of data and we take a parallel set of answers or observations, and once that's run through the model, it can infer and it can understand itself the relationship between these two sets of data and spit out its own set of rules. And what this looks like in reality is the microscopic image is taken on site, and a parallel source of data is also collected. So that would be something like the settling velocity. We run that through a training cycle of the model, and the model learns and understands the relationship between these two data streams. And once that model is trained, we will be able to present the model with a new microscopic image that it hasn't seen before, and it will determine what the settleability is, what the settling velocity, or the SVI, of purely just the visual characteristics in that image, which will allow then the operator to take preemptive steps to prevent microbial upset, polluting events, etc. So the tech is new in this space, and we're working with the leading scientists who have deployed the first SVI determining model using just microscopic images. And we're also working with the University of Alabama to deploy this early model with their postgrad environmental engineering class. And we, as I mentioned, we are early stage, so I want to know about the biological issues in your facilities. I want to have two-way conversations and learn about how this can be applied to your challenges and whether you've seen these yourself. So with the potential of potentially leading to a design partnership further down the line. So happy to take any questions. No? Cool, thank you very much.